In this segment, we will talk about z-score and also show how to use Excel to find that value. Whenever we have extreme values in the dataset, we use z-score. And z-score is represented by x minus x bar, where x is the observation, divided by s. Capital X bar stands for sample mean and capital S stands for sample standard deviation. The thing to remember about z-score is it takes care about the outlier. If the z-score is less than -3 or z-score is greater than +3, then we have presence of outlier in the dataset. Now let's look at this data. How many minutes do you have to wait to be served in a fast food restaurant? Suppose it's 7 minutes, 4 minutes, 9 minutes, 7 minutes, 3 minutes, and 12 minutes. Let me use Excel to get all the measures of central tendency that we have done in the previous lecture. Let me erase this stuff. I guess what I can do is I'm going to erase all this and I'm going to reconstruct everything again. So we start out with the observations, and so 7 4 9 7 4 9 4 9 7 3 12 7 4 9 7 3 12. Like the previous example, we'll go to data analysis, descriptive statistics, okay, and we look for the input range would be from 2 through A2 through A7. Output range would be C1 to D23, and we'll look at summary statistics and okay. In order to construct the z-score, these are the things we need. We need to look at the mean, and also we need to look at the sample variance, and these are our x's. x1, x2, x3, x4 is right here. So we construct the z-score. What we ought to do is we use equality. Mean is, the cell for mean is D3. So we put a parenthesis. Make sure you put a $sign for it not to move. $3. I think I made a little mistake here. It would be A2 minus D3 close parenthesis divide by D7. Again, please make sure you put the $sign if you do not want this number to change. And in order to calculate the z-score, we want x bar to be constant and we want standard deviation or s to be constant. Once we have done that, we enter, and all we need to do is go at the corner and then scroll it down. I think there was a mistake here. So that's our z-score right here. So we can look, and since we do not have anything greater than +3 or less than -3, the data are pretty close to each other. And if you want to look at the coefficient of variation, again we should be able to do that. Coefficient of variation is standard deviation, which is d7 equal to d7 divided by d3 times 100. So that will give our standard coefficient of variation is 46.94. We haven't talked about skewness and kurtosis, but we'll be doing it shortly. So again, if we look at the z-score is, okay, I'm sorry, z-score is in this table. We can color it in yellow. So I'm sorry, this one should be yellow as well. So this is our z-score right here. So 0, 9.2, 0.06, 0, negative 1.21, 1.52. So this is one way of expressing z-score. So for the time being, I'll move back to my previous lecture. The next thing we're going to talk about is the next thing we're going to talk about would be quartiles. But before we do that, let me just say a couple of things about z-score and how can we determine the shape of the data by looking at mean and median and so forth. Again, looking back into if our data is symmetric, when mean is equal to median, and we have 0 skewness, we have a symmetrical data where the area to the left is equal to area to the right. Next, when mean is greater than median, mean is greater than median is positively skewed or skewed to the right. In that case, you can draw the graph here, skewed to the right. Again, I need to erase this. This is not skewed to the right. So in this case, blue line is mode The purple line is median, and the green line is mean. So this is mode, this is median, and this is mean. However, when mean is less than median, the graph is skewed to the left. In that case, how the graph is going to look like? Mean is less than median. In that case, the blue line is mode. Again, mode is always the peak. Then the red line is the median. And green line is the mean. So when I give you an example, when I give you a data set and you calculate the mean, median and mode, and if the mean tends to be lower than median, we can say the data is skewed to the left. And on the other hand, if we have the value of mean exceed that of the median, we can say that the graph is skewed to the right. So that's one way of looking at it. So the mode is always the higher point. We need to find out if mean exceeds median or mean is lower than median. With that, okay, the next thing we're going to talk about would be the quartiles.